here we go. This is something that only happens once or twice a year.
The ice blows across the lake and it builds up on the shoreline and starts piling on top of each other. It's amazing, and the sound is unreal. Okay, let's get back inside by the fire and program some NABU.
What's up, my NABUers? Oh, this is an exciting day because guess what? Well, I think you know, CPM, Cloud CPM launched today. So I'm really excited, super stoked. Let me give you a little overview, see what's going on. So first things first, you need to get the new internet adapter, okay? NABU.ca, click on downloads, internet adapter, download, and grab your flavor. Okay, so let's take a quick little look at how this bad boy works. It's not very complicated. When you load up the internet adapter, what you're gonna end up with is a bunch of channels like we used to have. And now under the channels, we have Cloud CPM. So just choose that, make sure you're started, and turn on your computer. I'm already in there, let me just restart it. What you're gonna see first is the BIOS load. There we go. It downloads the binary of the operating system and the CCP. And we are booting, so you see the top right where it's got a little R flashing. That's showing us that it's loading from the internet or from the file system. And now we can dir, and here we are. So for example, we can jump into, let's go to our G drive. I have all this documented online, so you'll be able to find out what files are included, and you can add your own disk images as well, so you're not just stuck with using mine. So let's just do a directory here of .com files, and you see here we got Zork. We got all the Zorks. Let's load up a Zork. Pretty exciting. So this is like pretty much the whole reason why I created Cloud CPM, is so that I can play Zork. When I saw it on the main menu on the cycle, and it didn't work because we didn't have a floppy drive, I was like, no. So yeah, here we are. Open mailbox. This is great, and it's about as fast as using a floppy disk, which is really cool. Now, I don't know if it's exit or quit to get out of here. Yeah, you can't go that way. Quit. Get out. You wish to leave the game? Yes, please. Actually, if I go to the B drive, you'll see a little D appear. D means that it's downloading the image. So that's what you're seeing with that. And there, so now in the B drive, I can't type very well. I keep putting this colon and semicolons next to each other. So let's take a look at here. I think this is our basic. B is for basic. And we got lots of stuff in here. So we can of course load Microsoft Basic. The command for that is basic. And then we can load up, like, I think my favorite one ever is animals, but let's load animal.bas. Boom. So we'll load that up here. At 30K free, right on. There we go. Am I thinking of animal? Yes, I am. Does it swim? Nope. Is it a bird? Yeah. Ha. No, I'm not thinking of an animal. So that's fantastic. So anyway, so this is all connected, all online. So your NABU no longer needs any hardware to do what it's doing. There you go. So that's showing that it's also reading as well. So that's what you get. Now, let's take a little look-see what's going on here. First off, back on our NABU.ca, we click on our Cloud CPM. I'll put this video up on here, but it's a chicken and egg, right? Who came first? So the web page came before the video. So I go over different things about the Cloud CPM. So for example, I go over what the loader is and how the BIOS works, and CPM2, what that is, and then how to use it. So steps on here, like what the different drives are, how to access the different drives. And then as well, if you're using the Mame emulator, I have some information for you here, because with the internet adapter, there's a default value of, I think it's like 15 or 20 or something of your TX delay. That was there for Retronet chat and Telnet, because we were having some performance issues with it. So you don't need that set for when you're using Cloud CPM. I would highly recommend that you change this to a 0 if you're using Mame, because otherwise you're going to go get lunch while you wait for a single disk image to load. Then we have the configuration hard drive. So this is what all the different files are on there, and their user areas. So these are all the basic files, etc. And then some information on how to load your own files. So if you want to have your own disk image, then follow these instructions, because that's how you do it. Now, let's take a look a little bit at this bad boy. So here's our code base here. Now, I don't think it's time today to go through what the CPM BIOS looks like and what it's doing, but I did manage to get most of it into C, as you can see here, which is super, super awesome. So I'm pretty excited about that. I did have to do a lot of assembler, I know, especially for the interrupts and things. It was just easier to do. I also had to do assembler, like I mentioned in the last video, is taking register values and then taking the values out of address space and then throwing them into registers, or vice versa. There's places in here where it's vice versa. Like for example, let's see here. Yeah, here. So taking a register and throwing it into memory address space, I could use it in C. So I mean, that was kind of a little ingenious idea that I came up with. So that works really well. But outside of that, a lot of it's C. Now, the naked, what this means here is that the functions for C, the compiler, they won't put any stack information in there. They won't return. It's just code. It's just pretty much like inlining a chunk of, well, it's not inlining because it's going to have a jump, but it's going to be just like whatever you write in there is just going to be in there, and there's going to be, that's it. Like it's not prepared like a function with return and everything. So, and you're not going to get your stack pushed away and all that kind of stuff. So your register is saved. So none of that's going to happen. So I have to do that myself. I restore and create my own stack. Something else I did too, which I should mention, is the version of CPM that's on here, which is Cloud CPM. It's 2.2. It's mentioned someplace in here. I did make a small modification to it, and I think it might be mentioned in here, is that I did increase the stack size for the user stack and the CCP. And I did that because I had some extra space, some memory space that I wanted to be able to use. And it's the reason why I did that is because I have a bunch of data above FF0E here. And the reason for that is because the way the interrupts work in CPM, or CPM, sorry, in the Z80. So I can go over that one day. I think that a lot of people are asking some questions, or a few people are asking questions, like how I coded all this and how I made it all work and how the Z80 works. So maybe I should do a couple more videos like that. I will tell you one thing that's been really useful for me is, here, let me restart with Mame. So again, this is running Mame with 0 TX delay. All right, there we are. Get in there, get in there. Okay, so one of the things that was super useful to develop this was using Mame. So John, if you're watching this, thanks so much, man. Making Mame was super great for the NABU, because I was not able to debug RAM, of course, with the NABU because it's physical hardware, and I would have needed to hook up probes. And like I said, I do have you've seen me in my previous videos use my Saley logic analyzer. That I could do 16-bit address space with it as well if I really wanted to, but man, this was so much easier. So one of the great things about this is, let's take a look at our memory view here. Where's my memory view? There we go. This was super useful. Let me throw it over here so you can see what I'm going to show you. Okay, so this is the RAM of the whole computer, right, as it is, and all 64K of it. And what's really wild is we can watch it in real time. Okay, so I'll restart the Mame emulator here. So I will hit F5 to continue running the program, hit F3 on Mame, and there we go. And you saw a bunch of information flash in there for a second. That was actually the ROM loading. And now this is all cleared out because the BIOS clears everything out. So it clears off just so it's easier to see when I was debugging. And you can see here at the very beginning of D290. So a lot of times when people are writing BIOS, they like them to start specifically at like a very even number. Like when they load CPM, like at say D000, you'll find that's really common. But because I was able to shrink my BIOS down and do a few other things, I'm just using values that are the exact size of the CPM. Okay, there's no reason why we shouldn't be. Let's use up all our bytes. And if we go down here through all of our code, you can see here these flashing values. This could be a stack. It could be some variables. The great thing is that if you take a look at this window here, which I'll bring over, you can actually see the SP, the stack pointer. So that's really nice because we get a chance to see where it is. So right now it looks like it's at DE7A. So DE, yeah, we're actually pretty close. We're down DE right here. Yeah, so this actually is the stack. That's why it's moving around so much. That's kind of great. So there's stuff getting pushed onto it and pulled off of it. And if we go down a little further here into our code, like our BIOS code, you'll start to see it. And here it is here. Here's our NABU BIOS, right? Right at the end, and this is where Cloud CPM starts. Now this is really neat to actually see what's happening. So this chunk of space right here is actually the receive buffer for the HCCA. And we can actually watch information pop in there. Now what you're seeing here in this big chunk, this is actually a double buffer of video RAM for text mode because I'm using text mode. And I don't know if you remember in a previous video I'd mentioned that I double buffer the text mode because it's way faster to give up those little bit of 960 bytes for such a huge performance improvement for scrolling. And the reason is because the NABU has built-in video RAM. So the only way to talk to the video RAM is through the VDP, through the video processor chip. Now it doesn't actually have any commands for doing block copies of any sort. And it kind of does. It had this thing called blast or something, blitz or blasphemy, I don't know what it's called, but essentially what it means is that when I write or read from video RAM, it'll actually increment the address for me, so I can do like an LDIR in assembly, and I can actually copy a huge chunk of it into system RAM. But then what I'm doing is I'm constantly taking RAM from VDP and having to use 960 bytes to throw it back into the VDP again. So I just keep it in system RAM. Why not, right? And now this allows me to be able to not only see what's on the screen, which is super cool. Now, like, watch this. I'll type in, I'll go back to our main window here, and I'll type in DIR, and we go over here. When I hit enter, look at that. See? So whatever appeared on here is on here. So this is our double buffer. So what I'm doing for scrolling is I'm using this as my source, and I'm copying from this into the VDP. So when I get to this, to scrolling, so let's just get down there and start scrolling, you can see how it does it. And it's super fast, right? Which is really great. Then you also see down here, there's a big chunk of memory here. This is we can get into this in some further videos, so let me know in the comments if you would like to hear me get more in detail about this stuff. But this is our caching for CPM for the drives. And then further down here, we have actually our stack that I use for the BIOS. So pretty wild, eh? And then finally, the reason why I started this little bit of in-depth discussion here is because at where is FF00 right here, you got a couple bytes here. You see these little bytes? Well, those bytes are for the interrupt. Now the way the Z80, and I mentioned I'll do a further long video about this, is that a Z80 interrupt on IM2 mode, you have to specify an address space that follows with 00. It's just the way it works. And the reason why is because when an interrupt occurs, it's called a mapping interrupt. You can have up to, 250 or 128 maps, different devices that can interrupt. And what will happen is they each take up 2 memory spaces. So this very first thing we see here, CCF0, which is actually the memory space F0CC, if we go to that memory space, we're going to find the interrupt for the receive of the HCCA. So when the interrupt occurs, it says interrupt 0 has occurred, and therefore it adds 0 to this value, and this memory space is what it's going to jump to. It's going to take care of that interrupt. And then if you look over, this is FF because I'm not doing anything with that. That's actually the HCCA TX interrupt. I don't need to do anything with that. If you look over here, we have an F0 ED, and what that is that's the interrupt for the keyboard. So if we follow this through, it'll be the keyboard. So what'll happen is every time you press a key, it'll go to FF00. It'll say, okay, FF00, and the interrupt for the keyboard is index number 2, right? This would be index number 1, index number 0. So what it does is it adds, 2 times 2. It adds, because it's 2 bytes per, right? And there we go. There's our interrupt for the keyboard. Pretty wild, eh? So it's pretty fun working on this. I've been really enjoying it, and I'm really excited to see you guys do it too. Because I mean, come on, man, we get to play Zork finally, and we no longer need to worry about getting hardware like a floppy drive for the NABU. We don't need one. We got it. It's all working. It's all fine. Throw your disk images on. If you want to create your own disk images, like I mentioned, at the bottom down here, way down at the bottom of our webpage, we got all the information to do it. Download the CPM tools. Here's all the disk definitions. Bam, 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 bam. I also mentioned in here too that I'm going to take the BIOS and I'm going to make it so there's a configuration file for the BIOS so that you're going to be able to specify a file that you can load your own BIOS files, your own CPM and everything in there. And that's it. Now, where I'm at next is just going to play some games, fine tune it. There are a couple bugs in it still. This is version B, I don't know, 0.4B or whatever it is. So we're going to do a few things in here. I'm going to do a few things in here that are just going to tweak it so that things work better and we don't get as many crashes. And yeah, so put up with that as I go along with it. But in the meantime, the next step is going to be add the CPM. I'm so excited I can't even talk. The CPM 3.0 stubs into the BIOS so that we can start running CPM 3. And then we can start running other things too that are CPM compatible with the BIOS, like Z80 DOS or ZDOS. There's different DOSes we can start running, which is going to be really neat because that's going to be fantastic. And here, the last thing I want to do too is if I start looking closer into the main menu of NABU, they do have a little chunk of area which has its own BIOS routines. Right now, I think we've gone over that, or we've talked about it in other videos. Here, if I were just to blam in here and show you a file you can get on NABU's or NABU.ca website, it's called. There's a BDOS for CPM, but there's also. Let's see, where are we here? I got to go down further into our document. Okay, so there is a bunch of stuff that the main menu for NABU will take care of. It has a whole BIOS that loads in, and you can do things like load files and directories off of the network adapter, and it gives you information about that. You can do things like, we can keep further down here, you can talk to the sound chip, you can create windows. There's a whole bunch of different calls you can do here. You talk to the human input device, which is your keyboard or your joystick. Let's see, we'll go a little further here. Yeah, here we can go. We can get into video screen device driver. So we have function calls. See call number A2H, A3H. So this works the same way as the BDOS works. Essentially, is you put in your register C, you put in the function call you want to call, and then register A is your return value. So it gives you the parameters essentially to be able to call these different things. Now, there's my memory space and this memory space might not add up. However, by looking at what these commands are, for example, attaching to I/O device, or this is actually just connecting I/O devices together, getting information from the keyboard, and if we go further into some of these, there are things like talking to registers for the video, talking to audio registers, getting patterns from the image, putting a message on the screen. A lot of this stuff is pretty basic, so I might be able to even just reproduce some of this. But let's take a look at what the disassembled version looks like first and see how much we can use. But the point to this is that if I can recreate this or copy it out of the main menu and put it into my BIOS, we will actually be able to run from the command line NABU software. So you'll be able to type in Pac-Man or whatever it is you want to play, and we can have a folder or a drive with actual NABU software in it. How cool is that going to be? And in order to do that, we'd have to strip the segment data out of the file, which is something that I've already done anyway. I did this a long time ago. If we take a look at any of my cycles here, you'll see here that these are all just .nabu files, and a .nabu file is indeed, as you know with Internet Adapter, a .pack includes the segment headers. A .nabu file is just a binary, like what you'd have with Homebrew. So these are actually .nabu files. So, for example, the main menu, which would be 1, 2, 3, 4, 5, 6. So it would be all these zeros and ones. There we go. So looking at this, you'll see up at the very top here, there is no segment data. So I've already prepared these files for this step, which would be making it so that we can run them from a command line. So this is the longest video I think I've ever made for you guys, other than a live hack. I apologize, but I guess it's excitement, right? I mean, heck, we are doing actual real CPM right now. Look at this stat. Oh yeah. This is fantastic. How much? Look at that. We got 8 megs free. What a great, awesome hard drive. Imagine how much that would have costed in well, I don't know, when is CPM from? I don't really know that much about CPM. I was talking on the Discord today, and had mentioned that earlier up here. I don't really know much about CPM outside of the fact that Gary Kildall, I went to his house in, was it Pacific Grove or someplace? I can't remember. It was pretty awesome years ago, and after watching some documentaries. But yeah, and especially I think he was a guest star on that show on YouTube. I used to watch it all the time too. Computer Chronicles. You ever watch Computer Chronicles? I think that's something you guys should really be watching. Computer Chronicles. Get in there. Chronicles. Yes. Yeah, it was awesome. So Gary Kildall was in here, and it was this is actually the house that I got to see. I went to go see. Yeah, that's really neat. The Gary Kildall special. Cool. If you get a chance, watch these episodes on YouTube. They're fantastic, and you get to see like some real cool style and shades. Oh yeah. Okay. I'm done for real. Go play on your NABU CPM, Cloud CPM, no floppy drive, no SD cards, just raw bytes on the internets. See you guys soon.